Here's like a question listed on the bottom. There are 4 functions graphed. I will tell you for an absolute fact that one of them is sine, one of them is cosine, and the other 2 are something having to do with sine and cosine. So, take a look at that. Maybe consult your neighbors. Which one of those is sine, which one of those is cosine? And then ask yourself the 2 that you didn't select. What are they? Cool. So, which one's cosine? I hear an A. Do I hear a second? I hear any alternatives? Cool. Why A? Y-intercept's a good way to check. Yeah. Right, whenever you see like a multiple choice matching graph thing, like find an input that distinguishes them, try to plug in that input. It looks like A is the only one of the lot that goes to the point 0, comma, something positive. Oh, cosine of 0 is something positive, sine of 0 is 0. So. Not the only way to have thought about it, but I think that's a good way too. Which one's sine? Well, let's start with this. Sine is not cosine, so it can't be A. Tell me something you know about sine. Passes through the origin. Sine of 0 is 0. Can we eliminate any options based on that? Which one? B. Cool. Can't be. So C or D?
Is it D?
I hear a D. I think I agree, but why?
Because going from cosine to sine, you shift left by pi over 2.
Awesome. Cool. Yeah. So sine is a shift of cosine in that if you start at sine and shift left by pi over 2, you get cosine. Take this and shift left, then that value will go to the wrong place. That's a reasonable way to do it. Yeah. So you said okay. Nice. Yeah.
I just have a question regarding like calculus and stuff, or calculus. Are they going to be using like trigonometry heavily in calculus as well?
Yeah, it is. Yeah, so trig functions have some really exciting properties between the 2 of them. In that calculus gives you yet another connection between them. So this is me going off script. So there's the graph of sine, and like this is a chalkboard drawn graph. What would you say the slope of that thing is close to 0? It's only positive. It doesn't look too extreme. It turns out the slope is 1. Oh, coincidentally, cosine of 0 is 1. The slope of sine is cosine. And there's like a cool fact that we certainly won't prove in this class, or use it anyway. But that's an important fact in calculus, because it lets you do all of the differential calculus you want with trig functions. There's a very explicit connection. Nice. We'll explore some other connections between them, and we'll do a lot of that today, in that we're going to fill out this table, which corresponds to symmetry properties of trig functions. And to fill out this table first, I think first I want to identify, so B and C didn't get used? What would you say B and C are in terms of sine and cosine? No, so secant graph, like, it looks like this, right?
Which is like the inverse of them.
It certainly is an inverse, but which one? Because like inverse can mean different things. The additive inverse is like stick a negative sign in front. The multiplicative inverse is do 1 over, that'll get you secant. The functional inverse will do something different. Let's see, B is in the list. So look at the graph of B. Which graph does it look most similar to? In terms of maybe a flip.
A.
A. It looks like you could go from A to B by flipping over the y-axis. So what is B? What flips a function over the y-axis? Nope, flips a function over the x-axis.
The inverse of cosine, no, the cosine of inverse x.
That'll flip over the line like y equals x, right? Like that's what the inverse function does. Just the additive inverse. Just
Oh, inverse.
right. It looks like this is the same as that, but flipped over the x-axis.
Yeah.
That just makes all the outputs negative. How about C? What function looks most related to C in terms of maybe a flip?
The sine of negative x.
Ooh, coincidentally, that is correct, because you could flip it over the y-axis. That would do it. I'm going to go for something simpler. I'm going to put the negative on the outside,
Okay.
which we can, because sine is odd. So let's label these. So let's see, this one was cosine x, negative cosine x, sine x, negative sine x. And I am going to jump down now to, in the notes, let's look at these graphs. So here's some computer-generated graphs of some shifted trig functions. So here's the first one, cosine of x plus 2 pi. Of the functions up there, which one does it look like?
For the cosine of x.
I think it looks like cosine. All right, its y-intercept is at plus 1. How about sine of x plus 2 pi? What does it look like? People agree with sine of x? It looks like it goes through 0, 0, and it starts ascending. Take a moment, fill out the remaining entries in that list, and we'll notice some facts that we'll put in the table above. And you can like talk to each other in this process. Shoot, it's not even a test. You can like, as long as you're not creepy about it, you know, you got any percent on. Cool. Let's do it. Cosine of x plus 4 pi.
Negative cosine of x.
Cool. Was that cosine of x?
Yeah.
Cool. Yeah, happy. Sine of x plus 4 pi. So far, so good. Pi minus x inside of a cosine.
Negative cosine of x.
I hear a negative cosine x. There is sine of pi minus x.
Sine of x.
Looks like just sine of x again. So we're seeing some symmetry properties here. Cosine of pi plus x. Sure looks like it's negative cosine of x. Sine of pi plus x. Let's see, it starts at 0, 0, and starts decreasing, like negative sine of x. Cosine of pi over 2 minus x. Looks like sine of x. In fact, that's an identity that we've basically already listed. Like it's that like shift by pi over 2 fact. Sine of pi over 2 minus x. Looks like cosine x. Oh no, we did it with a plus, not a minus. That's okay. Nice. People agree with those entries? Nice. So, those things will tell us formulas about trig functions. They tell us that for absolutely any integer k, if you take cosine and add an extra bunch of 2 pi's to the input, you don't change cosine. And that makes perfectly good sense, right? 2 pi is like a full revolution. Full revolutions don't affect trig functions. So, in the case of cosine, 2 pi minus x, I can ignore that 2 pi and just get cosine of minus theta. Oh, cosine's even though, we already knew that. That's the same thing as cosine of theta. Negative sine theta. Cosine of pi over 2 minus theta apparently should be the same thing as negative cosine theta. Sine of pi over 2 minus x, so sine of pi over 2 minus theta should be the same as sine theta. It's just a different name of variable now. When you replace an input by pi plus that input, you make the sine and cosine just negative what they used to be. When you do pi over 2 minus theta, you turn cosine to sine, and sine to cosine. Cosine of pi over 2 plus theta is negative sine theta. Sine of pi over 2 plus theta, as we've already seen, is the same as cosine of theta. So on the one hand, you can see all those facts from a graph, but if you really want to know why those are true, think about what the units are, what trig functions mean, and you'll see these facts appearing from a unit circle. And let's see exactly that. So here's what the next significant portion of this lecture will be. Let's explain why these things are true by drawing pictures inside of a unit circle. So let's do it. And the first one, we already kind of know the justification. In that we said it. We'll establish these properties and use them to fill in the unit circle. All right, we have some entries in here we haven't completed yet. We'll complete those entries by the end of this discussion. Theta plus 2 pi k. So, as we just said, what sort of angle does 2 pi times k correspond to? What sort of angle does 2 pi correspond to? Nah, it's pi over 2. Full revolution. 2 pi is a full revolution. So pi over 2 is a quarter of a revolution. So if I give you an integer k, 5, 7, 10, 2 pi k corresponds to k full revolutions. So if you see an angle like theta plus 2 pi k, you can think of it as fast rotating by theta. Oh, nope. By k full revolutions. It's grammatically awkward now. K full revolutions. And then by this additional angle theta. Those full revolutions, so if I start at 1, 0, I spin around the unit circle a bunch of times, and then I go forward by a little bit. Did those full revolutions actually matter? Nah, you can ignore them. So, whenever you see some extra 2 pi's inside of a trig function that you just don't want to deal with, don't deal with them. You can erase them. That feel good? And not terribly deep at all, right? Like, full evolutions don't matter, and that's just the arithmetic way of saying that. Negative angle. So, all of these will correspond to just thinking about what these operations do to angles. So here is a picture. There is a positive angle of theta. And so a negative angle just corresponds to an angle of that same size, but going clockwise instead of counterclockwise. Or you just rotate in the other direction. So if there's an angle of theta, I'll try it in blue. Down here is an angle of negative theta. Yeah, that seems pretty good. What symmetry relates them? Reflection over the x-axis. All right. And let's see. So what am I going to do? I'm going to think about where this sends x, y coordinates. And there are 2 different types of x, y coordinates right now. So maybe I'll call that x coordinate, one's cosine, comma sine, x old and y old. This new point, I'll label it as x new, y new. Of course, I could just label it as sine, cosine negative theta, sine negative theta. So let's work with that. That reflects over the x-axis. How does that change x-y coordinates?
The x stays the same, y is going to be negative.
X stays the same, y becomes negative. So x new is the same as x old. Y new is negative y old. Just because I reflected over the x-axis, that makes y coordinates negative. Feel good so far? All right, let's put this together. So cosine of negative theta, I could also think of it as cosine of 2 pi minus theta. That is x sub nu. That's the new x coordinate. You just told me that's the same thing as the old x coordinate. And which trig function gives the old x coordinate? Cosine. Nice. So cosine negative theta is the same as the cosine of theta. Feel pretty all right? All right, same thing but for sine. What does this tell you sine of negative theta should be the same as? Let's go through the list. Sine of negative theta is the new y coordinate. But in terms of the old y coordinate, what is the new y coordinate?
Negative.
Yeah, it's negative the old y coordinate. Which trig function gives the old y coordinate? Sine. So sine of negative theta is negative sine theta, which again is something you already kind of knew. By looking at the graph, you could just inspect and see that cosine is even and sine is odd. Now we're seeing it from the point of view of the unit circle. And now that we see it from the point of view of the unit circle, let's use it to do something. So this fact says that we're placing an angle with negative that angle, or 2 pi minus that angle, is the same as reflecting it over the y-axis. I'm going to take out this unit circle. We're going to see what we can fill in. So we already had all the entries in quadrant 1, right? All right, we did a bunch of like right triangle studying to get those. Well, let's see. Here's an angle of negative pi over 6. Do we already know trig functions of pi over 6? Yeah. Let's reflect these over the over the x-axis and see what happens. So, what should that x-coordinate be?
Be the same x coordinate.
Same x-coordinate as that one. Yeah, perfect. So root 3 over 2. What about the y-coordinate? All right. And I guess we haven't talked about tangent explicitly yet, but what should tangent be then?
Be negative.
Yeah, it'll be negative what the thing above is, because tangent is a slope. When you reflect over the y-axis, you make a slope negative. Right, this line has like the same slope as that line, but it's going down instead of up. Fill in the other two, just as easy. X coordinate stays the same, so that'll be root 2 over 2. That'll be 1 over 2. Negative root 2 over 2. Negative root 3 over 2. Cool. Seem pretty all right? And what do you think? Given that these angles, these numbers are so closely related to those numbers, do you think you even would need those written down on like a test or something? Think you could get away with just quadrant 1? Yeah. There's an observation to make as long as you remember what reflection does. Nice. All right. So we have sine and cosine. I guess we just figured out that tangent becomes negative. To figure out the remaining entries, let's just do it. I think let's pick one. We'll do together algebraically. I'll give you all a moment and have you do another one algebraically, and then we'll just fill in the remaining blank. Which one should we talk together all together? Secant, cosecant, or cotangent? Secant? Cosecant? Cotangent. All right, I think the cotangents have it. It'll all be very similar analysis. So let's try to think about what the cotangent of negative theta is. What ratio of trig functions gives cotangent? Like what is it in terms of sine and cosine?
Cosine percent.
Cosine over sine. Right, cotangent is x over y. So it'll be cosine of negative theta divided by sine of negative theta. Ooh, I'm off screen. So let's work with that. Do I already know what happens when I see a negative inside of cosine? Yeah, what happens?
It's just cosine.
Just becomes cosine. So the numerator of this is just cosine of theta. How about the denominator?
Base negative.
It becomes negative. So the negative pulls out of the parentheses. Like that?
Oh.
Sine of negative theta is negative sine theta. All right. So now let's try to go back and simplify. Now that you see that written down, what does that simplify to?
Negative.
Right here on negative cotangent. Right, I see a negative in the denominator. Negative doesn't need to be in the denominator. You could pull it out front. 1 over negative 2 is negative 1/2. Then I see cosine over sine. Ah, but you just told me cosine over sine is cotangent. Cool. Seem all right? Think you could do something pretty similar with secant and cosecant? Yeah, maybe I'll write down the first step. So if I want to work out secant of negative theta, what's secant in terms of sine or cosine? 1 over cosine. How about cosecant? What is that?
1 over sine.
Nice. And the input I want to plug into those is negative theta. I wasn't on screen, but nobody stopped me. So I'll give you a minute. Pick one of those and work out what it becomes. All right, let's come together. What do you get when you do this to secant of negative theta? What do you get?
Over cosine.
1 over cosine? All right, the negative inside of the cosine doesn't matter. Cosine is even. What is 1 over cosine of theta? What's another name for that? Secant? Anyway, just go back using the same fact. All right, what about when you do this to cosecant?
Over negative sign.
About that? Let's see, the negative I could pull out, leaving you with negative 1 over sine, which maybe is exactly what you said. What's 1 over sine?
Just cosine.
Cool. So this tells us something. This tells us cosine is even, secant is even, tangent is even or odd. So remember, even means you can ignore a negative inside of the parentheses. Odd means you can pull a negative out of the parentheses and put it out front. So, tangent, even or odd?
Odd.
Odd. You can pull the negative out of the parentheses, put it out front. Sine,
Also,
also odd. Cosecant,
same thing.
tangent, cotangent.
That too.
Cool. So we see exactly which of these are even and odd. And not only that, this agrees with the graph we had earlier. There's the graph of tangent. That look odd? Nice. Cotangent, also odd. Secant, even. Cosecant, odd.
What was your justification for determining it was even or odd just for looking at the negative?
Yeah.
It was in the parentheses, if you could take the negative out of the parentheses, put it in the front.
Yeah.
Okay.
And that means when you make the input negative, the output becomes negative. So that's why it corresponds to that number. When the x value becomes negative, so does the y. Cool. Feeling good? All right. So a lot of today is more of the same of that. So we have now justified this second line in that table. We'll do some more of them. We'll step through them one by one. I think that we'll cut this one a little bit short because we'll see what's happening pretty quickly. So let's think about an angle of pi minus theta. And in order to understand all of these identities, I'm going to think about, well, if I draw an angle of theta and then an angle of pi minus theta, how do they relate? So to do that, I think, well, here's what we'll do. On the one hand, rotate up by an angle of theta. There's just theta. Next, I want to rotate by an angle of pi minus theta. So that'll be like rotating by pi and then backwards by theta. How big an angle is pi?
180 degrees.
180 degrees, also known as half a revolution,
Yeah.
whichever way you want to think of it. So let's do that. Let's rotate forwards by theta. And now I want to rotate backwards by, no, forward by pi. Now backwards by theta, because I want to do minus theta. So put me up there.
Yeah.
Cool. Let's draw it here. So I don't have to like blow out my shoulder. So there's an angle of theta. To get an angle of pi minus theta, first go forward by pi. Then I go backward, no, let's use this color. Backward by theta. So this angle corresponds to pi minus theta. All right, now I'll add the same decoration. There's x old, y old. This new point I will label as x new, y new. And now that we have that picture, let's ask the same question as we did for negative theta. What symmetry relates them?
With the y.
Flip it over the y-axis. Nice. All right, and same analysis. How does that change x, y coordinates? Or possibly just look at that picture. X new, y new, how do they relate to x old, y old?
X new is negative X old.
Yeah. Perfect, and that will tell us something about cosine on the next line, so depending on how ahead of schedule you want to be, you can go ahead and fill in that next line. How does the y value change?
Same.
Doesn't change. Cool. Now we have everything we need to go and figure out how sine and cosine change, and it's not anything deep. Cosine of pi minus theta is the new x coordinate, which you just told me is negative the old x coordinate. Which trig function gives the old x coordinate?
Cosine.
Cosine, awesome. Do the same thing for sine. You get sine of pi minus theta is the same as that's what goes in this line. Are you gonna call for sine theta? People agree? Nice. So, right, what are we doing? We're like going through the logic that says that these identities that the graphs told us should be true are actually true.
Should closer.
I don't know what you're talking about. Of course it is. I appreciate you pointing that out. That would have been like really upsetting if I made it to the next page and then found out there was a typo. Do you call it a typo when you're writing? Like it's not, right? Because you're not typing. Anyway, so we know what cosine of pi minus theta is. It is the same as the cosine of theta. Sine of pi minus theta is, nope, negative the cosine of theta. I did it again. Could we figure out all the remaining trig functions? Yeah, I think, let's take this mindset. I do one, you do one, and then we fill in the remainder together. So, which one should I talk through? Secant, cosecant, tangent, cotangent. Secant, cosecant, tangent, cotangent. All right, I think I saw some for cosecant. Let's walk with cosecant. All right, so let's do that. Let's do this like two different ways. We could do this by either translating to the xy coordinates or by thinking in terms of sine and cosine. Translate to sine and cosine? Walk in terms of xy coordinates. All right, I think I saw half a vote. So let's do the same thing as we did last time, and then maybe we'll do the other one too. What's secant in terms of, what is cosecant in terms of sine and cosine?
1%.
It's 1 over sine. So this will be 1 over sine of pi minus theta. So I guess here's the idea that I'm trying to get across here. If you want to know something about one of the trig functions other than sine and cosine, translate to sine and cosine and then see what you already know. What can you tell me about the thing in the denominator of that fraction? Well, it looks like it's sine, but with the pi minus theta in there instead of a theta. Looks like this line tells me what to do. So this is the same thing as just 1 over sine theta. Oops. That shouldn't have turned on the screensaver already. All right, and what is sine of theta? Nice. Cool. Think you can do the same work for the remainder of them? I think we won't. I think I'll write down the things that go in the blanks, and maybe we'll decide if we want any of them discussed. So let's see, cosine just becomes negative, so the same walk will apply, but the denominator will become negative. So we'll wind up with negative secant theta there. Tangent, let's see, it's sine over cosine. The denominator will become negative, so I can just pull that negative out. Cool. Folks feel pretty good?
Do you want one?
Oh, yeah, sorry. Nice. So here's the last one that we'll do by using this, like, draw a new angle and then just like see what the unit circle says. Or at least well, we'll see what happens. So let's think about an angle of pi plus theta this time. So same thing, rotate forward by an angle of theta, that's already drawn. The other one will be rotate forward by an angle of pi, then forward by an angle of theta. How big is pi? How big a rotation? 180 degrees. It's half a revolution. So go half a revolution, and now go forward by theta. So let's draw that. Go forward by a half of a revolution, so there's pi, and now I still need to do theta more. All right. What's symmetry? Flipped over the origin. So x and y both become negative. Or I guess if they were already negative, they become positive. They both get multiplied by negative. So that tells us everything, doesn't it? In fact, I think we can skip a bunch of the intervening logic steps. What's the cosine of pi plus theta? Or maybe we can just say them. So cosine is the x-coordinate. So cosine of pi plus theta is the new x-coordinate. How does the new x-coordinate relate to the old x-coordinate? Negative. So cosine of pi plus theta will be negative the old x-coordinate. And what is the old x-coordinate? Cosine. Could we do the same thing with sine? What would we get? I hear a negative sine theta. All right. So cosine became negative. Sine became negative. Secant and cosecant are just the reciprocals, so they'll become negative for the exact same reasons we've done algebraically a few times. Let's think about how tangent and cotangent will change. And I don't know, like, should I talk through tangent or talk through cotangent? Tangent? Cotangent? All right, a few more for cotangent. Maybe you suspect that the walk will be pretty similar either way. So let's do it. So cotangent of pi plus theta. What is cotangent in terms of sine and cosine?
So move the paper up.
Yes. Cosine over sine. Ooh, that's exciting. Because now I know what happens to cosine and sine when there's a pi plus inside of the parentheses. What's cosine of pi plus theta? Negative cosine of theta. I can use this line. Same thing with sine. And now, like you know the game, it's simplify and see which trig function it is. What simplifies there and what trig function does it become?
negatives cancel out.
Cool. Negative divided by a negative becomes positive, so I just have cosine over sine. And that is cotangent. Think the same thing will happen with tangent? Yeah. So let's even just put that in there. And additionally, those two facts are facts you already knew. What's the period of tangent? It's pi. So when you add pi inside of the parentheses in tangent, it doesn't change tangent. There's why. Period of tangent is pi. So there's like a side thing that we notice. Okay, that's not in the way, but it's bothering me. When did that notification appear? I don't like that. Okay, that's a good feeling. All right, so let's look at what's left on the list. The things left on the list are what does pi minus do, and what does pi plus do? And we definitely have enough time to get through pi minus. For pi plus, we'll combine some things we've already done. Here's the way that I want to think about pi minus theta. I'm going to draw a right triangle instead of a unit circle, because we can, right? Trigonometry says things about circles, it also says things about triangles. So here is a right triangle. This angle is theta. It's a right triangle, so how big is that angle? What is it in radians?
Pi.
Pi over 2. Right angle is pi over 2. That angle labeled question mark. Can we figure out what that angle is? In fact, it looks like people are just doing. Tell me, what is the angle labeled question mark? Anyone feel stuck like they don't know how to even begin figuring out question mark? Cool, then let's begin. So someone who didn't just raise their hand, how do you start? What is the fancy equation that lets you determine question mark? Oh, well then more hands should have gone up. What do the angles of a triangle have to add up to?
180.
In degrees, 180, but what are radians, so pi. So theta plus pi over 2 plus unknown adds up to pi. Oh, that looked like an equation that's familiar, like something that we did while we were thinking about triangles last time? Yeah, that's an important thing to just remember. If you know some angles in a triangle, you can know the rest of the angles. I guess solve for question mark. Question mark's the thing I'd like to know. So I guess subtract the pi over 2 over. Feel pretty good? So here is the fancy fact. An angle of theta and an angle of pi over 2 minus theta. So two angles that add up to 90 degrees. They both appear as opposite angles inside of a right triangle. That's not quite what people would call complementary angles, but it's, similar. All right, feeling pretty good? So what will we do now? We will use SOHCAHTOA. And I guess I need to have something for the hypotenuse. I'm going to use hype for the hypotenuse. So SOHCAHTOA. Cosine of theta is what in terms of right triangles?
It's just x. Or the adjacent, or sorry, yeah, no, opposite.
It'll be adjacent, divided by hypotenuse.
Wait, are we going off of theta or theta minus pi?
We are thinking about theta right now.
Okay, yeah.
But you know what? Next, let's do theta minus pi over 2. Oh, the color coding is all on, that should be baby blue. And the thing in green should be pink. Oh, theta minus pi over 2, what is, so same thing, it'll be adjacent over hypotenuse. What's the side adjacent to that angle? Y. We'll translate back to trig functions in a moment. Y over the hypotenuse. Because y is adjacent to that angle. When you're using SOHCAHTOA, you think about which side is adjacent to that angle. And now let's do the same thing for sine. What is sine theta? So sine is opposite over hypotenuse. I want theta first. So if you start at theta, the side opposite is y.
I'm getting mixed up with the
Oh yeah, I get it. Easy thing to do. Next, let's do the other one. Oh, because I'm screwing up the color coding too. God damn it. How many people wrote down the right thing even though I wrote down the wrong thing? Okay. All right, question mark is pi over 2 minus theta, so all those should be pi over 2 minus thetas, not thetas minus pi over 2. Anyway, so now we'll do the same thing for sine of this angle. So sine is opposite, which is x over hypotenuse. Now we'll try to look for connections. So cosine of theta minus pi over 2 is y over hypotenuse. Where else do you see y over the hypotenuse? Sine of the original angle? Oh, cool. So cosine of pi over 2 minus theta is the same as the sine of theta. Sine of pi over 2 minus theta is x over the hypotenuse, is cosine of theta. So, sine and cosine swap when you do pi over 2 minus, which agrees with what we saw on the previous, on like the cover page. And I think I'm slightly low on time, so let's just see if we can intuitively suss out what the rest of these should be. So secant is 1 over cosine, and cosine and sine swap when you do this. So that'll become 1 over sine, also known as cosecant. So secant and cosecant swap. And same thing with tangent and cotangent. Neato. So, with the 40 seconds or so I have left, I don't think I can complete the remaining line. So we'll do it, I guess, in quite a while, because the next day is review day for the midterm. So this homework will be pushed back to being assigned next week. Although there's nothing there that you don't know how to do. Use those identities to extend some information. This is basically the homework. It is literally the homework. Okay, I just translated this into the Canvas page. If I give you an angle that is, whose cosine is 3/5 and is in quadrant 1, that's enough information to determine sine. Oh, and then just look at all these entries. You know what all of those are in terms of sine and cosine. So if you know what sine and cosine are, you know those. These next 4 don't require much more. They just require a little bit of algebra with those. So if you want to take a look at those now, you can. But it will be assigned as if it's assigned next week. Ooh, and if any of you like checked Canvas too compulsively and notice I haven't updated that due date, shoot me an email to remind me, because I might forget.
During your crossovers, because I was doing this on the homework a while back. I was done on like Tuesday with it, trying every other day, just doing a little bit, trying to do the ones I could. I can't get past like 2 of them of work. I was worried if I could stop that at all. I mean, I can show you now, but like I have a bunch of notes, like I feel like it's taking longer than a minute. Just
Yeah,
kinda
yeah.
talk over.
Yeah, can you make my notes come up today?
What time is it? Is it at 1?
1.
Yeah, there's no way.
Okay, cool. How do you feel about 2 o'clock?
I get done in Centennial at 2, so I could run over here really fast.
Okay, yeah, you don't even need to run. Around 2 o'clock, however, I'll just still be here.
Okay, perfect.
Yeah.
I'll be over there then.
Thank you.
I have a question regarding the test next week. So something's come up, I have a probation meeting on Wednesday. And I might be able to make it to class on time, but do you have a trigonometry